Topic 4, we are looking at transformations. Okay, so in the revision, we are going to look at 4 different transformations. The first one is rotation. Rotation means we are going to turn something. So we have clockwise or anti-clockwise. Clockwise is this direction, this way, and it's the same way as the clock. Anti-clockwise is the other way. Okay, so when we are doing rotation, we need to know if it's clockwise or anti-clockwise. We need to know how much we are rotating, 90 degrees or 180 degrees. And we need to know around which point we are going to rotate. For example, we might rotate around the origin, 0, 0. Okay. The next one is called reflection. Reflections means we are going to flip over the line like a mirror. Okay, so when we are reflecting, we need to know which line, what line are we going to reflect over. We can reflect over the y-axis, this is the y-axis, or the x-axis. Okay, if you cannot remember which one is y, which one is x, y goes down like this. Okay, so this is the y-axis. Okay, one thing to remember to know, when we are rotating, here we are turning the shape is congruent, they are the same shape. When we are reflecting, we flip it in the mirror in this line, these two shapes are also congruent, they are the same. The next one is translation. Translation means we move the shape, so maybe we might move it in the x direction, right or left, or we might move it in the y direction, up and down. When we move the shape, translation, the shape is also congruent. They are the same shape. The last one is dilation. Dilation means we change the size. Okay, we need to say what scale factor. For example, if it's a scale factor 2, it is 2 times bigger. And we need to say from which point. Maybe we make it bigger from the point, the origin, 0, 0. Okay, when we do dilation, the shape is not the same, they are not congruent. Okay, because it gets bigger. So let's look at question 1. On the coordinate plane, triangle RST, this is triangle RST, is reflected across the y-axis. Okay, where is the y-axis? The y-axis is here. Okay, it's reflected in the y-axis. Which ordered pair does not represent? Which ordered pair does not represent a vertex of the reflected triangle? Okay, so let's reflect all these points, all these vertices of this triangle in the y-axis. Okay, so for example, point R here, this is -5, 1. If we reflect it in the y-axis, it will go here, 5, 1. Okay, this is the new point. This point S is -2, -4. If we reflect it in the y-axis, it will be 2, -4. 2, -4. Okay, this is the new point. And this point here, point T, is 4, -2. 4, -2. If we reflect it in the y-axis on this side, it will be -4, -2. -4, -2. And this is the new point. Okay, so we need to see which one is not one of the new points. 5, 1. 5, 1 is correct. 2, -4. 2, -4 is one of the new points. Okay, -4, -2, -4, -2, this is one of the new points. So -2 and 4, we don't have -2 and 4 on any of the points. So this is the answer. It's not represent a vertex in the reflected triangle. This is this point here. Question 2. In the following coordinate plane, triangle RST is reflected across the y-axis and then translated 1 unit up to S dash T dash. Okay, this is a new triangle reflected across the y-axis. So this triangle is reflected across the y-axis and then translated 1 square up. We need to find the coordinates of the new point for S. Okay, so let's find S. S is here. Right now it's on 5 minus 1. Okay, first we are going to reflect it in the y-axis. This is the y-axis. So it's going to be reflected here. This is 5 minus 1. So here it's going to be minus 5 minus 1. Okay, and then it is translated 1 unit up. So it's going 1 square up. Now the new point is minus 5, 0. And this is our answer. Okay, so S dash, we started from S, we reflected in the y-axis and we moved it 1 square up. Now the new point is minus 5, 0. So the coordinates is minus 5, 0. Okay. Question number 3. A triangle has vertices A, which is minus 2, 7, B, minus 2, 4, and C, 2, 4. It is translated 3 units down. Translate 3 units, not down, sorry, 3 units to the right and 2 units down. We have to find the new coordinates. What are the new coordinates of vertex A? So we are looking at vertex A here. Okay, so minus 2, 7, A is minus 2, 7. A is minus 2, 7. And now we have to move it 3 units to the right. If we think about it, moving left and right is the x-axis. Okay, if we're moving to the right, this is plus. So 3 units right, this is our x, we're going to plus 3 to this number. Okay, and 2 units down. Down is our y-axis. Up and down. This is y. Okay, so up is going to be plus, so down is minus. So minus 2 in my y direction. This is my y, so minus 2 here. So our new coordinates for A, minus 2 plus 3, this is 1. 7 minus 2, 5. That's our answer. The question is asking, is the new figure similar or congruent to the original? When we move a shape, this is translation, translate. When we translate, we move the shape, and the shape is the same shape. It is congruent. So it is not similar, it is congruent. Okay. And the last question, question 4. A square with vertices 1, 1, 2, 1, 1, 2, and 2, 2 is dilated, this means get bigger or smaller, by a factor of 3 from the origin. Scale factor of 3. So we are timesing by 3. Which of the following is one of the vertices of the new square? So we are going to write all our points 1, 1, 2, 1, 1 2 and 2 2. Okay, and we're going to times them by 3. So 1 times 3 is 3, times 3 is 3, 2 times 3 is 6, 1 times 3 is 3, timesing all these numbers by 3. 2 times 3 is 6, 2 times 3 is 6. Okay, so these are the new points of the new square, the big square. Okay, which of the following is one of the vertices of the new square? 6 3, yes, 6 3 is correct. 3 9, no. 1 3, no. 4 4, no. So the only one that is part of the new square is 6